Okay, so this is the module 2 for moderation and mediation. So moderation, you're looking at how does a variable modify a relationship between our independent variable and dependent variable. So basically you would need to explain that relationship beyond primary predictors that are available. And see how it impacts that relationship. So, for the purpose of this module, we'll be looking at specifically a continuous dependent variable as well as a continuous independent variable. However, a moderator will be dichotomized, but it will be an independent variable as well. As far as what we have here, we're looking at the relationship that the interaction term also has on y. So more specifically, in this situation, b not impacts intercept, b1 impacts slope, and b2 would let you know whether you see a different intercept, and b3 lets you know whether there's a different slope or difference in slope, which is specifically pertaining to the impact of that interaction of the independent variable and moderator on y. So for the first model, we see that while everything is significant, the interaction is not. The interaction is not significant in relation to its impact on y. So what you would expect to see are still different lines, meaning there is a difference in relationship between whether our moderator is at 0 or 1. However, you would likely see the same exact slope for both lines, but they would still have different intercepts. And here we are. So the green line is more specifically when x2, which is our moderator, is equal to 1, and then the blue line shows that our moderator is equal to 0. So as you can see, they are a relatively parallel line, and that is because the interaction itself was not significant for that model. As we look into model 2, we see that everything is significant with the exception of B2. And B2, you're looking at the effect the moderator itself has on y. So within this, you would expect to see different lines as well, but the slope is more so impacted when x2 equals 1 and not when x2 equals 0, which is our moderator again. There wouldn't be a intercept difference, and then you would also likely not see a difference in slopes. So as you can see, with x2 equaling 0, there is a flatter line as opposed to when it equals 1. You see intercepts as well as slope differences between both lines. But as more specifically, when x2 equals 0, you do not see a slope difference. In model 3, you see that everything is significant, meaning that our interaction has a significant effect on y as well as x1 and x2. Within this, you expect to see different intercepts, a slope impact, difference in intercepts are going to be shown as well as difference in slopes. And as you can see, this is it laid out, where you can see that there is significance for both lines, showing a moderation effect. So with mediation, you are more interested in explaining the relationship due to proximity to x. So the mediator should explain that relationship in a way that would not just be through x and y. So as you can see here, C shows the partial effect with the moderator, and then you would also be looking at the direct effect here. So we'll be looking at we'll be looking specifically at the difference between the direct effect and the partial effect when you include the mediator versus not. Also, with a mediation, there is a temporal effect. So, kind of relating back to whether the variable is going to be more proximal or distal. And in general, the independent variable relationship is just more important because of that. So we use the bootstrapping method that gives you an advantage to include because of the increase in power, as opposed to like other methods like Sobel tests and everything, which are more impacted by sample size. For both of these, in all of the models in this entire module, we are using a sample size of 200, but random sampling was used to here around 1,000 estimates to get a range. And you want to make sure that the effect was not just due to random sampling fluctuation. So as you can see here, the X1 highlighted shows that there is a significant relationship between the X and the mediator, which is very important for mediation. And furthermore, you can see down here that when you do the model and include the mediation, there does appear to be full mediation. And the model itself accounts for around 36% variability. So that means that pathway A and B are both significant within this, as well as the relationship from X to Y, which would be pathway C. And when we're looking at more specifically whether the effect is going to be a direct or indirect effect, we see here that while the total effect is 0.58, around 0.213 is impacted from indirect effects, which would be the C naught from the previous model showed. Also, we would look at the confidence interval, which we got from the bootstrapping method. And you would, in this case, not want to see zero to show that there actually was an actual effect. If you did see, if zero was included within this, you would see that there was not. So for the second model, we can see that there is also significance within the A pathway. However, there is a slight difference here. So when you include the mediator into the model, the pathway for part B is not significant, which is right here. So here you can also see that there is likely due, or that is likely due to the directive effect of X and Y, basically taking more or having more control. That more likely has to do with the correlation that we would see between the relationship of the mediator and Y compared to the correlation of X on Y and Y. And you can see here that the indirect effects of X and Y, or of X and Y, show that the mediator did not really have as much of an impact as you saw with the previous model. But however, overall, moderation will give you a lot of information regarding how a specific variable can impact the relationship between X and Y. While mediation, you would be looking at why or how that relationship moves through that variable instead. So both are very important tools within regression and looking at the different relationships.